as I had before. Basically what we have at this point is we have the volume of the first two triangular prisms. But the idea is that there are many, many, many triangular prisms. So it would be more accurate to say plus dot, 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 and then just add up all the triangular prisms that we could possibly have between points A and B. And in fact, we're taking the limit as W approaches 0, so that we have infinitely many limits, right? Many triangular prisms. And so this is the formula that actually is the definition of the integral. But how do we get from this formula to the integral? Because we want to get to the integral so that we can plug it in our calculator, right? That's what the calculator understands. Well, here is the generic formula for finding the integral, or finding this how this limit of the sequence equals the integral. So what you'll see is that I'm sorry, just a second. What? No, I'm doing something now. Sorry about that. So you'll see here that f of a is all that very similar to this part of our expression here. In fact, I'm going to just pull this out a little bit. In fact, we could set this whole expression equal to f of a, because what this is f of a times w, the same as here, f of a times w. And this, in fact, right over here, that's times w. This whole thing here could we set equal to f of a plus w, right? And so how do we get from f of a here to f of x over here? Well, you just change the a to an x, right? So if we wanted to take f of a to f of x, we would take this function, this statement here, and we would just replace the a's with x's. And so I'm going to simplify this a little bit. So it would be radical 3 over 4 times f of, this time, x squared. And that's it. That's what f of x would be. That is equal to f of x here. So then we can just take that and run it straight to the integral. So it's the integral from a to b, and then it's going to be of this thing right here, radical 3 over 4 f of x squared dx. And that, my friends, is our integral. You can, once you have the actual function, the actual ending starting points, you can plug this in your calculator and you'll get a very accurate value. All I can say is, through my time in mathematics, I've seen time and time again that it's so much more valuable to understand the theory and the actual mechanisms behind like any sort of math problem rather than just memorize a formula.